So kicking us off now in this discussion, do you mind breaking down for folks how exactly glove recycling works?
Yes, it is a very different process than what we are conventionally used to with plastics, which tend to be more dynamic, more capable of being recycled in a conventional way more times. Instead, with butadiene rubbers, NBR, you actually use two different derivatives of fossil fuels that need to be chemically purified. And then you need to basically irreversibly cure them with sulfur in a process called vulcanization. And so when you do that, it means that unfortunately, if you heat back up that nitrile butadiene rubber aggregate again, you're not going to get the same result. It's not going to melt back down into a semi-fluid that can be remolded. Instead, it'll burn, it becomes friable, falls apart. And so instead of being able to kind of go back to its original state and be used again and again and again, like the polyolefins that we recycle with HDPE and polypropylene, you actually have to chemically treat it and devulcanize it. You have to break those sulfur bonds, and that basically opens it up and turns it into a worse version of what it used to be, but it's still valuable and functional version of a binding agent for other types of rubber, including tire crumb. And so for our process, when we treat this material to recycle it, we're basically turning it into like a sticky binding agent to grab more tire crumb that can go into the production of industrial goods like replacements for cement, barriers, cones, construction industry, mud flaps on tires or on automobiles. And so it's a very different process. It's fundamentally not circular. It's a downcycling solution. But as you'll find out kind of in this conversation, that doesn't mean that it doesn't confer significant environmental benefits.
So you touched on it, but how does that process stand in contrast to plastic recycling?
Yeah, to simplify it is I can't go from nitrile butadiene rubber gloves back to gloves. I fundamentally have to take it into something that's a downcycled, lower use function, lower utility product in an industrial good or something that's going to be used fundamentally in a different industry. I can't bring it back into the life sciences. Now, you compare that to polypropylene, which is the workhorse polymer for laboratories. I can, so long as I can maintain adequate separation from specific other polymers in the lab, which is relatively easy to do, and Polycarbin's had enormous success doing in the past decade. I'm actually able to keep that material kind of in its same value function and turn it back into products that can be used by the same consumer in the same market time and time again. And the huge advantage for that is, unlike the nitrile, which will probably only displace one more product in its life cycle before it ends up in landfill, the polypropylene, the HDPE, all of those materials can displace 2, 5, 10 products in their life cycle, really compounding the impact. Now, I highlight that point because we always want to have circularity be the gold standard, but it is important to draw the distinction and also recognize that downcycling has its role when you can't do better. And so if there's no opportunity cost of downcycling, it is the preferred method instead of having something only serve one functional life and then end up in a landfill.
Yeah, I think that you're bringing up a great point, which is like, why are we still focused on gloves? And there's two reasons. Like this business, this recycling platform is not only focused on reducing carbon in the lab, and there's an opportunity to do so even through downcycling gloves, but it's also about solving a pain point and creating a culture of sustainability in the lab. Many scientists are obsessed with this waste stream. It bothers them how many times in the day they take off their gloves and dispose of it. And so we saw an opportunity to address another carbon intensive material, but one that was inherently very personal to many lab operators. So that's the opportunity that we saw. And although this is a downcycling solution, it has a clear environmental benefit as driven by the LCA. So Noah, maybe unpacking a bit how transport specifically impacts the sustainability of glove recycling. Can you dive into that?
Yeah, I like this question because there are many downsides to trying to recycle gloves that make it more challenging than conventional polyolefins. But one of the huge advantages is the compression ratio for transportation without almost any added mechanical augmentation of the material stream. And what I mean by that is it packs really dense. You can get 1,400 pounds per cubic meter on a pallet, which means that I can always fill a truck with 30 to 40,000 pounds per shipment, which fundamentally, according to our LCA, means that we are emitting 114 grams of CO2 emission per kilogram of material moved per 1,000 miles. And that's a complicated unit to kind of try to like conceptualize, but I would think about it like this. It represents 2 to 6% of the total CO2 emissions produced from the original virgin material. So it makes it so that transportation is actually not a heavy impact proportionally to the original material produced. And so just emphasizing one of the advantages of gloves is that they pack really dense, they store really they transport really efficiently, and ultimately that means that that transport is a lower proportionate impact compared to the rest of the process of producing the virgin material.
I think you bring up a great point, which is and we'll probably need to do a separate segment on this about LCAs specifically. But oftentimes within the recycling world, transport becomes a major focus, as it should be. But we always need to contextualize transportation in a supply chain based off of the overall carbon benefit of the recycling process, which is defined by what that material is turned into, how many use cycle it gets. So I just wanted to point out the fact that specifically for life cycle assessments, we need to be interrogating our supply chains to see where the carbon benefit occurs and contextualize the carbon impact of transport in light of it.
And beyond transport, what are some of the other kind of unique features of this material in the lab, James, that make it so uniquely suited for recycling?
Yeah. Within the laboratory, because of the nature of many of these workflows, gloves are uniquely suited for recycling because they're used in workflows oftentimes where they are protecting your assay from the operator or the lab user who's working in that assay. And as a result, there are opportunities to divert these gloves in a non-contaminated, non-infectious, non-hazardous capacity to direct them into a recycling supply chain. Um, what that means is that by engaging users, by understanding their workflow and their scientific assay, you can effectively divert these materials in a risk adjusted fashion. Now, gloves oftentimes are definitely used in some situations to protect people from their work. It's very important, therefore, to work with an organization like Polycarbin that seeks to understand your assay, seeks to understand your work, to make sure that you can integrate these solutions in a risk-adjusted capacity in partnership with the H&S.
Just two anecdotes that reminds me of. Um, we would buy a bunch of primers and we'd have to reconstitute the primers, and we'd be pipetting very small amounts of RNase, DNase, very expensive water. And we would always be judicious about changing our gloves. And I would think about how many pairs of gloves I would go through as I was like reconstituting primers, knowing now that if I think about this material being recycled, there's no chance that anything hazardous is going to come in contact with that glove beyond the purest water there is. And so it's nice to think like in those instances, those are workflows that are very low risk for potentially recycling that glove material stream. So it does bring me back to that work in the lab. Um, One last question that often comes up, um, and I think it's a good one, is where are we seeing the majority of glove waste come from?
Yeah. Obviously, within R&D laboratories, we see gloves used frequently. But what's been awesome in our work with a broader ecosystem and new industries is that glove waste, PPE waste, is found in a number of advanced manufacturing contexts. So within the life science and pharmaceutical industry, obviously, providing a glove recycling solution, a PPE recycling solution is quite relevant for drug manufacturing facilities, CDMOs, et cetera. But beyond that, it's opened up this conversation about sustainable operations, sustainable innovation, as we've started to serve industries like the semiconductor industry, like advanced product manufacturing. Very controlled manufacturing settings have an abundance of both glove and PPE waste products, making this a solution that's quite relevant to many of the landfill diversion goals and sustainable operation goals.
Thinking that I believe we've had food trucks reach out to us about recycling gloves.
Food trucks,
That is an industry we didn't know we were going to service, but we are more than happy to help ensure that those gloves end up in a better destination than a landfill and at least into the production of another medium utility product before ultimately they meet their end.
All right. So with that, we'll wrap up this week's Monday morning mailbag. If anyone would like to write in with some additional questions on a topic of their choice, feel free to reference the info right here at the top of the screen. Thank you, everyone.
Well, take care.